Hello guys and welcome to another tutorial. In this case we will be learning how to create very cool balloon simulations with a twist of some rigging. So stay tuned and watch the full tutorial.
Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you.
Here we are in the scene. So to begin with, the only thing I did is to create a simple tube, group in the top and group in the bottom. This is just a normal group. And with this, I created two things. First of all, I want to create the base of where the cables are going to be mixed. So what I did is to just do a simple poly extrude because I want to keep the normals of the geometry nice when they are in render. I just grouped the edge and I added a simple poly bevel. As you can see here, nothing crazy. I recalculated the normals. I don't know why, I just did it. And added a rest position. This rest position will be used for the noises. Then I used to multiply the rest by 5 because, well, you will see in the shading context. What I did is to merge these two guys. I basically just set this the same as I am doing here. We will go here in just a bit. And merging these two guys. I assembled them, just creating names, and I separated these two guys. I merged them a little bit, like I made them a little bit tighter because I am going to then be covering the lines which are created over here. Like I want to cover them a little bit, so they are inside this geometry. I then unpacked it and set the names of where it's going to be stored in Solaris. Basically inside the scene, the foreground, machine, base. And then I'm configuring the USD. So it's the nested group and components, nothing else. Over here, now you will understand why the transform. I did the same with the poly extrude to create an inside section of where I'm going to be sketching the points. And this is going to be called app. Well, I'm basically just doing the instant to the app section. I'm scattering some points here. I'm adding a wrangle, which basically this is just the ID. And here I am transforming this upwards to ray them together based on a vector going upwards. Now the same points which are here, I'm going to be translated to the top. I'm merging these two guys together, adding them together by attribute based on ID because the points here are the same points here with the same ID. And I'm resampling to get some more points for the simulation. Over here, I have the group top, which I am transferring here. Basically, the top group is going to be stored here, right here, as you can see. And with a group expression, I'm pinning based on the neighbor count 0 ptnum equals to 1. Basically, the first points of the primitives and the last point of the primitives are going to be grouped to a pin. And I'm deleting everything because I don't want any attribute. I'm using a balloon constraint here, visualizing the thickness, where I'm grabbing the rest length here, the length over here, divided by 2, because this is going to be for the radius, minus a little bit of an offset, as you can see. So this will always be dynamic, as you can see. The spheres will grow, but they will not overlap on top of each other. And then I am transforming the points. As you can see, I am rotating the top section. That's about it. With the balloon solver, this is what's going to happen. I'm just moving the top parts and the rest is just working. You will see there's a lot of wiggle here. I really don't care about it because we are going to be solving it in the next stage. For the next stage, this is very nice. I'm grabbing the simulation, adding a connectivity set to points so I can have, let's see here, different values per lines. And I'm creating a chop in. This is to grab a chop network. You need to create a chop network. And inside here, we will grab the geometry, which is animated. That's all it. And we are filtering the position. How does this look? Let's go into the animation editor. You can see we have the geometry over here. This is how it looks. And the thing we get to see over here, sorry, into the motion FX view, now we will see it's calculating. We will see a lot of things. So to begin with, I want to delete everything. And then I want to grab one of these. These are the points. Let's do it again. Let's do it again. Remove everything. And let's only add one. This is how it looks. If we press the H, we will see this is where the wiggle starts to begin working. So what I did is that as we go on, we go forward, sorry, into the animation right here, nothing is happening. But as soon as we start to get a little bit of wiggle, what we do is to start smoothing out everything. So now that's this cyan stuff is what we are getting. So no more wiggling because we filter it out. That's all I'm doing, nothing else. With the channel, I'm grabbing the chopnet, animated, and I'm not changing anything because the only thing I'm changing are the points. So with the time blend, what I'm doing here is to slow everything down with a post extend and set it to cubic. And well, we're going to be redoing the velocities. But doesn't matter, you can do this if you want. Enemy sampling, this is very important. This has to be constant, otherwise we won't be able to do what's coming next. We can go here to see, because making this constant point will make so that the point count is static. This is what we want to achieve. Now, with the time shift, I'm just setting the rest position over here. I'm just saving it. And we are also saving this to a file cache. This is curve post chops. This is what we have. Now, another connectivity. Why I did this here, if we have it here, I don't really remember. But it works. I mean, it's the same process, probably due to this for each. Now, leaving that aside, we can continue to the curves, time shifting all of them together. What we're going to be doing here are two things. First of all, creating the rig preparation and then creating the weights of the actual mesh. So we get the curves over here. We delete everything and we orient the joints. Orienting the lines are it comes in very handy, and we need this information so we can actually prepare our rigs. But the rigs only work if per point, as you can see here, per point we have a unique name. This is where having a unique point count comes in very handy, because we know we will always have a constant name. So these are the lines with names, and then we're capturing the lines. This is a way to work with what comes next, which is the bone capture via harmonic, which is a way just to capture weights into rig. I am also, because we lose some information, I'm sending back the class, the name, and the ID to these lines. So basically, the class, the name, and the ID. You can see we have everything here, and just setting this to place. And since we don't have the actual, we don't have the class attribute, I'm setting it again. I did it like this just in case the class attribute, when we do another connectivity, doesn't work. This is the safest way. We could try a connectivity over here, set 2 points to see what happens. Well, nothing happens. So we could just have done this instead, which is way easier. But I just wanted to make sure, because you never know when something is going to pop in and out, and sometimes this is the way to go. Maybe it's too overcomplicated now that I think about it. but it's just an workaround. So let's go into this. What's going to happen here after we have this preparation? This is an actual rig right now. Well, what we are going to be doing is to getting again the curves, time shifting them, doing a polywire. The polywire will have to do the same thing, the rest length, I mean the resample length divided by 2 because it's radius. Same thing as the simulation over here. And then we are copying again the class attribute. See, we have a -1, but over here right now we had 19. We do this for each of them. If we don't do that, we won't have the attribute class anymore. Then we're deleting all but the class. And going inside here, it's very interesting. What we need to do is to get the preparation of the rig. We need to create a meta import node. Now with that, based on the class, based on the actual class, which is in fact the iteration number 2, we will be deleting the actual class or iteration number based on the detail, which is in the spare input. To create a spare input, you need to create it over here as spare input, and then you just drag and drop it here. So per iteration, we will delete this. We will set it with a time shift, and we will prepare our TET embed, which if you see into the geometry, it looks something like this. And what this creates over here is that we can capture back our weights over here. The weight looks like this per point. If you see something like this, it means it is okay. We will do this for all of them. This will take a couple of minutes because it's a little bit heavy, but once we are done, we will have all of them already weighted and prepared for the rig. So this would be the character and this would be the rig. Why we decide to do this, I'm going to show you in just a moment. So we need to have the weights. I added the rest position. We have the lines, rest position, and the deformation over here. Why is this very nice? Because we can do various things. For example, we can do a rig pose over here, and we could, for example, bend it like a rig. See? Very interesting having this possibility. The way, or the main idea why I did this is because we do it, for example, with a point deform. Let's just do it with one line. I want to show you based on class. I'm going to be deleting this one, and in the same case we will be deleting it here. So if we do the same things, first of all, the point deform looks awful. The rotations are awful too. So we could, for example, use lattice. So we could do the same thing, set 2 points, and look at this. Now compare this. You see how they are not aligned to the actual angle, whereas this is. Of course, we are also having other issues, for example, the radius. Let's imagine that's okay. It is still misaligned. See? That's the main concern. So I did it with a rig instead. Now setting the normals, removing everything but these attributes. I think I do have something with adding connectivities many different times, and a fatal error. Great. So to continue the normals, this I'm setting the class again, which this is unnecessary, so we can delete this. I'm also setting a color based on the random. Oh, this is not unnecessary, apparently. Yeah, because this is at 2 points. Exactly. Yeah, the connectivity is at 2 points, so I can have the gradient with many different colors, so I can move them around and changing threads to recalculate the velocities, and setting the names of where this is going to be loaded into stage. I didn't cache this out due to errors during the rendering. One note to keep in mind of this simulation, this is actually not really colliding with each other precisely. As you can see, there are some issues inside the geometry. This can be solved basically via doing it differently, but I wanted to test out this idea. or doing a secondary simulation where we just post-process everything out, or with a detangle. The detangle looks something like this. This is the node where we can work with. So all of these are possible solutions, but these work, as you can see for the renders, pretty nicely. So this is the process we are at in subs. So working in stage, we can grab in the tube, which comes in as we set it, and the base. In Arnold, this is an Arnold tutorial, but you can do the same with Karma. I set everything into cat clark at length. Well, I didn't do anything. The adaptive error could be set to 1, for example, but I didn't do anything about it. And the displacement set to 0.01 and 0 value of 1. The same thing goes here. In this case, no auto bump. I just didn't have any displacement, but I have this just in case. So I set everything here, and with a simple downlight, we can start seeing with Arnold what's going on. So it's already looking nice, in my opinion. So let's work with just one geometry at a time. And let's remove this so it's a little bit faster. So what's going on here? This shader looks very nice, and it works using our rest attributes. So let's set this to dark so we can see it a little bit better. This is how it looks. And we have some materials over here, which are the tubes. This might look a little bit scary, but it's actually not. So let's go one by one. What's going on here? So if we go into the first step, this is just a simple tree planner of some scratches where we are using the display color, which is actually the CD. In stage it changes, and if we multiply, we can tint our geometry. We can color correct this a little bit. The only thing I'm doing is lowering the saturation, and this can be the subsurface color. We are also calculating the specular roughness, and the specular roughness is just a material which we don't have anything, sent via a tree planner, which is using the rest to calculate it, so it moves in space, and then we are remapping this so we can have more contrast. Those things combined output something like this. Very, very nice. But this is not enough, because I wanted also to create something different. And in this case, I wanted to have gold, but not gold everywhere. It's just gold on some scratches. And the scratches are made using the same idea of having a displacement texture, which is then sent through a tree planner, which is remapped and remapped again. So we can have really nice, sharp blends. This is the mask of this. And finally, I want to add some car paint. This is how it looks, which is using the color of the tubes, which is just the display color. And what I'm doing here is to setting the base to 0, the specular to 1, and this is the flakes complexity. If we add it, in this case it's blend, but in this case if we add it, it will go on top of the previous shader. So you will see we can have a nice look over here. Nice. So this is one of the shaders. The other one is just a simple color with a tree planner on the diffuse and on the roughness, nothing else. There is, and the other one, the other guy looks something like this, which is okay. I didn't need anything else. Now I created 3 different cameras, one being this one, another one being this one instead, and I just play around with the focus distance. So I basically added the camera, press enter, press set. When you press set, you will see this. And this is the point of focus, and this is how small or big you want the focus to be. And then I am animating this to be. So with these settings in mind, I go into here, then I set Arnold render. And what I did is setting this to GPU, which is way faster. The ray depth is set to 2 and 2. This sampling is adaptive, and subsurface to 3 and transmission to 3 and diffuse to 3. There was subdivision because I used to have displacement. The only thing happening here was that I decided not to use it and the last minute, which was basically just connecting this to the displacement over here. And on device, this is the GPU and AOBs. I don't need any of this. These are multiplied by 4. I don't know why. Oh, this is a mistake. These are the AOBs. Basically, you just need one RGBA. I don't know why I have 4 instead. Nice. And there's nothing else. The only difference is that I use the Prism setup, which is a way for me to send to the farm. But you can use an USD ROP, render ROP, and you can just configure this and set this to Arnold or Karma, whatever you have, and just click render to disk, and you will have your sequence. And to finalize, a really quick comp, because since this is only an RGB, I merged it with a white color. Then I adjusted with the keyer the luminance to key basically an effect after a permult, and creating an exponential glow with different settings over each one. When we merge everything with a plus and we multiply everything so I can have what a desired look, I can add it on top of actual work. We then have a color correction, which is very, very minuscule. Very minuscule. Then transforming a little bit so we can have a small, well, this is quite big, but a color aberration. And then distorting this over here. Yeah, let's distort. Cropping the accent overscan. Grading this with a radial. And just using this as a mask. And doing a new but more strong contrast color correction. Adding on top of it a tiny bit of noise. Having this, I render 3 things, A, B, and C, which we can see how they look over here. Oh, well, we can't, but this is the look. Very, very nice. Over here the same, and over here also the same. These are all the 3 different render. I hope that you like the video. Please leave a like, comment, and you have any type of questions, I will be there for you. See ya.